Hello everyone, my name is Oluwaseun Okweyi Martins, and in this video, we'll be looking at how to write a literature review in 7 easy steps. However, before we go into that, we want to know exactly what a literature review is. So a literature review is a survey of scholarly sources. Now, a literature review itself is a survey of scholarly sources. So that means that you can't just pick any literature to review from sources that are not scholarly based. So you have to ensure that the source you are taking that literature from is a scholarly source. And a literature review is always on a specific topic. So if you have a research work, your literature has to be centered around that your topic, so you can have a broader knowledge of the extent of the work that has been done in that space that relates to your topic. So literature review is a survey of scholarly sources on a specific topic. So what literature review does for you is to make you understand the extent of the body of work that has been done in the research space that you intend to work. So you want to know the current knowledge, and knowing the current knowledge will allow you to identify the relevant theories and methods, that others have used in approaching the same problem you want to find a solution to. So it helps you to identify theories in terms of the mathematics around it, and also if there are other theories, it might be a work that has to do with maybe science, that has to deal with some theories that you have to know. So it helps you to know what scientific theories are relevant, in solving the problem you intend to solve, and also the gaps in the existing research. Now, what we mean by gaps is that what area is still left, unresearched in that very space that you are trying to focus on. So from the body of work that has been done, you will see where people have worked, and even from their own work you can see what is left to be done. So from there you know what the gap is in that space, so that you can apply this knowledge to your own maybe your own thesis or your own journal paper that you intend to put up on that same topic. So that is what literature review is in the nutshell. So we'll be looking at the 7 steps by which you can do a literature review. So here are the 7 steps that we're going to be looking at in actually doing a review of a certain journal paper or a conference paper. But before you apply these steps, you must ensure that you have already sourced your literature from a scholarly source, and also that the literature itself is specific to your topic. So once you have gotten journal papers and conference papers, that is centered around your topic, then for every thesis, there's always a chapter 2 or a chapter where you do literature review. So how do you now review a paper, in your own write-up for your research? So here are the 7 steps. Number 1 is who authored the work and what year. So the first thing is who authored the work and what year was that work published. And the second step is what did the author or authors do. So what exactly did they do, in that work. The third one is what method did the author or authors adopt. So you want to know what method was adopted by the authors. We talked about literature review being an avenue whereby you can familiarize yourself with theories and methods that is centered around your topic. So from every literature you want to review, you need to know what method did the author or authors adopt in their own work in achieving their own results. So the next thing is what is or are their results. So you want to know what results was achieved from the method that they applied, and The next thing is what is or are their conclusion or conclusions from their results. What are they concluding? And also what is or are their recommendation or recommendations, on the conclusion that they have. And the final step is any reported future work, because in some literatures, the authors themselves would provide the future work. They will equally report it in their research. However, some don't. So you need to look at it and see what future work, that is where the gap that you are looking for is. That is where the gap is. So these are the steps. So the next thing we'll be doing is we'll have a certain paper, and we see how we can apply these steps in actually doing the review of such paper. Okay, so let's take this paper for an example. So let's assume I have a topic that relates with path planning in mobile robots, and I already have some papers, and this happens to be one of the paper that I want to review in my own work. So how do I do this? So like we said, the first thing is to know who authored the work and in what year was that work published. So let me just open my Word page here. Let me split my screen in this way. So this is the paper itself. So the first thing I want to do is who authored the work. So I look at this, I can see the list of authors on this very paper. I can see here, this is the first author. This is Oluwaseun Opeyemi Martins. And also here is Adefemi Adeyemi Adekunle. And also here is Olatayo Moses Olaniyan and Bukola Olalekan Bolaji. So the rule is this: when the authors are more than two, then you only pick the surname of the first author and you use the French word état, But when the authors are just two, for instance, let's say this paper was authored by Oluwaseun Opeyemi Martins and Adeyemi Adefemi Adekunle. Now, who authored the work, which is the first step, will have been Martins and Adekunle in this case. So in what year was it? So if you look at it, the year that this work was published is year 2022 here. So it will now be 2022. So the first step of who authored the work and in what year has been answered just with this. However, we can see in this work that the authors are more than two. So in that case, it will be the surname of the first author, then et al. In this case. And because the word et al. Is not an English word, then it will be in italics in this form. So that will be Martins et al. In bracket 2022, because you are starting the paragraph where you are making this review with the name of the author. So that is why it's only the year that is in brackets in this case. But if the name and the year is coming as the last word in that paragraph, then it will be the entire name and the year will be in parentheses and with a full stop and a comma after the et al. But if they are just two authors, then it will be and Adekunle like we did before. Adekunle, comma 2022. However, this will not be in italics in this case because the authors are just two. But in this case, we know that we have four authors here. So that is why it will be et al. And because we are starting the paragraph with the name of the authors, then it's only the year that will be in bracket in this case. The author will be in italics. So the first step of who authored the work and the year has been answered. So the next thing is, what did they do? What exactly did they do? Now from the topic, we can see here that the topic reads an improved multi-objective A-star algorithm for path planning in a large workspace, design, implementation, and evaluation. So what they did is captured in their topic. So you can say there are many variations to this. It depends on how you want to put the topic as what they did in your own reference. So in this case, I can say Martins et al. 2022 proposed an improved multi-objective, or I can say proposed the design, or I can say presented the design, implementation, and evaluation of an, you can just come and copy this for a large workspace and just paste here. Sorry, let me just do this properly here. For a large workspace, full stop. So Martins et al. 2022 presented the design, implementation, and evaluation of an improved multi-objective A-star algorithm for path planning in a large workspace. So that's the second step. The first step is who did the work and in what year, and the next thing is what did they do, which we have captured from the topic. So the next thing is what method. They already talked about improving the A-star algorithm for path planning in a large workspace. So from this topic, we know that the A-star already exists. However, what these authors, what they did is to improve on the existing A-star algorithm. So how did they do that? So we can get some more information from their abstract in this case. So if you look at the abstract in this case, it says improved path planning algorithms should minimize algorithms processing time, increase path smoothness, and shorten path length, all of which will be extremely beneficial for mobile robot traversal in large workspaces. As a result, an improved multi-objective A-star algorithm for mobile robot path planning in large workspace was designed and implemented in Python 3.8.3 in this study. In the test cases, the proposed IMO A-star is evaluated in a large workspace with dimension of this, and its performance was compared to that of traditional A-star algorithm. When compared with traditional A-star algorithm, the results show that. So here they are discussing their results after the comparison with the traditional A-star. From their topic, they said improved multi-objective A-star. So one other information that we can get is what are the multi-objectives that they are actually speaking to. So the multi-objectives can be gotten from here as well. We can see that they talked about the processing time, to minimize processing time of the algorithm, to increase the path smoothness, and also to shorten the path length. So you can come here and say that the improved A-star or the improvement that was done on the traditional A-star is to minimize to minimize the algorithm process time, comma, increase the path smoothness and shorten the path length. Or you can say the multi-objectives achieved or you can say the multi-objectives achieved are minimal algorithm process time, just correct that, minimal algorithm process time, increased path smoothness and shortened path length. So this is just giving more information about the work they did in this case. So what method did they use in their work to achieve this minimal processing time, increase path smoothness and to shorten the path length? How did they achieve it? That is the method they adopted, which is the third step in this case. So for the method they adopted, you need to come to where the paper has the probably the materials and method or the methodology that they adopted in their work. So from there you can, make a summary of the method that they used in the work. So for instance, coming here to the material methods for this very paper, so we can see in the first paragraph here, they are talking about the A-star itself because they worked on an improved A-star. So they first of all explained how the traditional A-star, how it works. So from here we can see the A-star computer algorithm is a pathfinding graph search computer algorithm that is widely used and all of that. So, but in their own work, they are proposing an improved multi-objective A-star, which they have given the acronym as this IMO A-star. So from here we can see that they came here and said the proposed improved multi-objective A-star, on the other hand, address the difficulties observed in the traditional A-star operations. It verifies its nodes in the search space, calculates the heuristic function and generates the obstacle map, and it saves the generated obstacle maps, workspace model, and the robot configuration to a database. So from this very statement, the researchers in this case are trying to tell us how different is their own A-star from the traditional A-star, which they have been discussing from here. So we can just come and select this portion of the work and see how we can summarize it into the literature review that we are trying to put together. So we can just copy this and paste here, and from there we can see how we can summarize that to fit our work. So here is saying that proposed IMO A-star, which is what they are working on the other hand, address the difficulties observed with traditional A-star. Now the problem that they have identified is this lengthy process time or processing time. The path is not very smooth, and also the path length is usually long. These are the problems they have identified with traditional A-star, and they are addressing in their own work. That is why they called it a multi-objective A-star algorithm. And the multi-objective that they are working on is to ensure that the A-star algorithm processing time is minimized, the path smoothness is increased, and also the path length is reduced. So here they are telling us how they are doing that. They said the proposed IMO A-star, on the other hand, addresses the difficulties observed in traditional A-star operations. It verifies each node in the search space, calculates its heuristic function, and generates the obstacle map. and then saves the generated obstacle map, workspace model, and robot configuration in the database. The stored information is then used to generate the optimal path for the same robot configuration and workspace model at different source and target points at a later time. This reduces the execution time. So this is how they achieved this minimal algorithm process time. They have explained how, and they told us that from this their method, which they discussed here, the execution time of the algorithm is reduced, allowing it to be used as a real-time path planning algorithm. So there's a certain equation 1 which shows the traditional A-star model and the flowchart that shows the procedure of the IMO A-star. So what we need to do here, let me just remove this part, we don't need it. So here is just to say, okay, so one can just say the proposed method verifies each node in the search space. So we can just say the proposed method verifies each node in search space, and just copy up until this point and see how that fits in. However, you still need to check for plagiarism, so one will see how you can do that as we go along. So look at what we have here. It says, so this HU that you have here, what it is, you can get it from here. So we can see that the heuristic function is what the HU is. So I can just copy that and remove this symbol of HU here. So this is what we have. It says the Martins et al. 2022 presented the design, implementation, and evaluation of an improved multi-objective A-star algorithm for path planning in a large workspace. The multi-objectives achieved are minimal algorithm processing time, increased path smoothness, and shortened path length. Now, the proposed method verifies each node in the search space. We can change this to the workspace. In the workspace, evaluates the heuristic function and generates the obstacle map, and presents or outputs the obstacle maps and stores the output, obstacle map, workspace model, and robot configuration in the system or to the system's database. So the stored information is then used to generate the optimal path. This stored information is then used to output the optimal path for the same robot configuration and workspace model at different. This source can be your start node, and go node at a later time. So this is the method they have used in minimizing the process time, so that once they have the robot configuration and the obstacle map already in the database, in place of the A star, generating the obstacle map and the workspace model every time you are running the A star, once you already have it in the database, the system just calls the same information for the same robot configuration and only prints the optimal path. However, this optimal path again is a path that the length has been shortened and is a smooth path. So how did they achieve that? Here they are telling us the path length objective. One of the objectives that they addressed is the path length, which is this shortened path length. So how they achieve that? Said the goal is to create a path that is short, that is as short as possible, and the path length is a goal to be minimized. The evaluated Euclidean distance between the extreme points of a segment is its length, where the Euclidean distance between the 2 points is given with this model. So what they want to do is to ensure that they minimize the Euclidean distance between two nodes, which is the start node and the goal node. So they want to minimize this very mathematical model. So that is how they achieve their optimal path. So what one can just write here is to say that the optimal path presented minimizes the, let me correct this, minimizes the Euclidean distance, which is, or let me just say the Euclidean model as presented by, minimizes the Euclidean model as presented by, because they got that very model from this reference 21 and 22. So one can just go to their references and see that reference for yourself, which is 21 and 22, which is these two authors in this case. So you can try to equally look at these two authors that they reported here, or just leave it at minimizing the Euclidean model in this case and put a full stop there. So for the path smoothness, which is the other objective that they worked on, here they are telling us how they achieved that as well. So we can see here the path smoothness objective. The goal is to keep the path as straight as visible by keeping the angles between the succeeding segments of the path as near 180 degree as possible. So as a result, the robot follows a path with fewer turns and consumes less energy. The path smoothness model is presented. So this is the model for the path smoothness that they also minimized. So one can just say here that the optimal path presented minimizes the Euclidean distance model and the path smoothness model. So this is the model that they equally minimized, so that the difference between the angle between segments, which is this alpha I, and 180 degree is as minimal as possible. So the minimal the difference between 180 and the angle between two segments, the closer to a straight line that path segment would be. So that is what they have done. So that is what we have represented with this sentence that we have here, saying that the optimal path presented minimizes the Euclidean model and the path smoothness model. So once you're done with the method, the next thing is what results did they achieve. So you can either go to their results and discussion, which they have here, to expunge their results, or you can go to the objective to see what results they presented. So here we can see that when compared with traditional A-star, results show that so here again you can copy here and see how you can fit into your work. So what you have learned now is that they compared the IMO A-star which they are proposing with the traditional A-star. So you can just come here and say that the results showed that on comparison with the traditional A-star, the IM, or let me say the proposed algorithm presented a reduced process time of this percent, as they have reported, of this percent, the reduced process time of this 99.8%, comma, improve path smoothness of this and reduce path length of this. So this is the results they obtained on comparison with the traditional A-star algorithm. So you can just see how you can fit that. So here they're saying the results showed that on comparison with the traditional A-star, the proposed algorithm presented a reduced process time of 99.8%, improved path smoothness of this 45%, reduced path length of this, reduced path length of this, and reduced number of random turns by this percent. So that is the result. So what is their conclusion? Also, you can see from there, they are saying that as a result, it should be considered a viable alternative to the traditional A-star for mobile robot path planning in a large workspace. So they are saying that from here, this is what they are concluding and recommending. However, you can also go to their conclusion and recommendation to see what they are actually saying before they came down to that conclusion. So here you have the conclusion. It says the design IMO A-star for mobile robot path planning is in a large workspace is discussed in this paper, as well as the implementation in Python 3.8, Anaconda, and all of that. 4 test cases were used to do the performance evaluation. So what is their conclusion? So here they are listing their conclusion. It says, despite the change in start and target points, as well as the addition of new obstacle in the workspace, the average process time of the IMO A-star after the pickle file generated in case 1 is approximately this. This is where they got that result from. In comparison with this, it improved the smoothness So this is just the highlight of conclusions on their results that they are presenting. So, and also here they can see they also said that the study discovered that the IMO A-star outperforms the traditional A-star in general, and it may be thus a viable and may be thus considered a viable alternative for mobile robot path planning in a large workspace. So here, for your own conclusion, you can just equally state that this shows that an improved path planning algorithm for mobile robot this should be capital. Improved path planning for mobile robots can ensure its better performance in a large workspace. So what is the next step after the results? So we can just check our steps. So their conclusions, their recommendation has been taken to any reported future work. So if you really look at their presentation in this research, they are not stating that they have implemented this improved IMO A-star on a mobile robot in terms of real-time implementation. They only worked, on Python with this IMO A-star and the A-star. So you can just say that for the future work, you can say the merits of the proposed algorithm can be better evaluated when implemented on a real life mobile robot. So with that, you can say you have, reviewed this work. You have the name and the author, the name of the authors and the year it was published, what they did up until here, how they did it, the results they achieved, the conclusion and recommendation, and also the future work in this case. So what you can do to your work, if you have Grammarly as an add-on to your Word, you can just click on Grammarly to see if there's any grammar issues with your work, or you can just wait a bit, and if there are none, so here you can see there's some minimal issues, probably comma, some sentence issues that you might want to change. You can just check them with Grammarly, because most times when we type, sometimes we make some of these errors. maybe you leave out an article or something like that. So Grammarly can help you to make such corrections on your. Also, there's the Writeful, which is another tool for checking your grammar, particularly when you're writing a research work like this. So you can just click on check documents. If you have your Writeful installed on your Word, and just click on check documents. So also you have its own suggestions. So you can just see here saying change goal to targets. So that's just the two. This is presenting. So from there you can say you have done the review here. So with that, we have come to the end of this video on how to do a literature review in 7 steps. Thank you very much for your time, and we'll see you in other videos.